Hi guys, my name is MAF. MAF is an acronym of my real name, and I'm here to start with my new course of C programming. I decided to present this course live on Facebook and YouTube, so please subscribe my channel, and you'll be learning very good things starting from this amazing language, the C programming language. And then if you like it, we're going to start another course on C++ as well. And after that, I pretend to show you lots of features, how to apply these insights in order to have control to some devices like robots, a little bit of artificial intelligence, machine learning, and also cryptocurrencies, which is also an area of my interest. And I also have a very good interest on um, blockchain and cryptocurrencies. So let's get it started, our course on C programming language. So today, the topics I'm going to be presenting are only three: an introduction to our course. Then we're going to talk about data and information. When we're talking about data and information, we have to talk also about numeral systems. I used to say numeric systems, but I wrote the numeral systems, and also units of information. Okay, most of you probably know lots of things about these topics, but don't worry, because this is not going to be all theory. Today, we're going to be talking about theory and how to manage all this information by ourselves. But in the future, we're going to use the C programming language to perform calculations for us. So in the whole course, we'll talk about concept of data and information today, and then on the next lesson next week, we're going to talk about structure of a program, of a C program, with some exercises, some things that we're going to talk today. We will perform some exercises on next week. Types of data. The C programming language has three basic data types: characters, integers, and float numbers. Each of these basic types has some subtypes. I like to check whether my sound is fine or not. Okay, let me just. Okay, that's very fine. I have a good mic and also a good cam. So if something's not quite fine for you, let me know in the comments, please. And also don't forget to subscribe Tekniikka. The channel is Tekniikka High Tech. Okay. Facebook, YouTube, Instagram, and Twitter. The name is the same. So variables and modifiers. Just focus on variables. We're gonna be talking about variables in order to manage the data types, the numbers, letters, text, and other kinds of information, some objects and so on. We're going to be putting inside variables. Like in math, you used to talk about variables, but don't worry. We'll learn everything in the practice. Data input and output, operators, sequencing, conditional statements, loops. Conditional statements, loops, and sequencing are three very important artifacts to create algorithms. When we're talking about algorithms, we're talking about the steps to create a program. And when you creating a program, you firstly create an algorithm, like a plan to create your program. And in order to create good algorithms, you have to understand quite well how to sequence your algorithms and also how to use conditional statements. Conditional statements are very important, even in the real life, because you have to take decisions every day, and the programs also need to take decisions. There are some programs which are intelligent or more intelligent than others. And this is all about conditional, okay? This is all about conditions. And loops are repetitions, okay? Even us, in the real life, we repeat ourselves doing what we do. The programs do the same. Computing is an imitation of the real life, okay? The computer brain is mirror, some mirror to the human brain. So then we're going to talk about arrays. We're going to be creating lists, matrices, and vectors, okay? Pointers, dynamic memory locations, and we'll finish the course talking about functions. But we are going to create a relation between all the topics, okay? Don't worry. When we talk about dynamic memory locations, we talking about how to manage the memory, the RAM memory of our computer. For those who don't know what a RAM memory is, it is random access memory. This is the memory which the computer uses while you're running your programs. That's the RAM memory. And your own programs, the program you're going to be learning in this course, will also use that memory which all the programs use. And the memory has some spaces, and your program will have its own space. And that space in the memory you have to control for your program to be quick, okay? To be acting with good performance. The performance is very important. On the last topics, we're going to be talking about performance, okay? Because the people don't like to use programs very slow, okay? That's a problem. So let's go ahead with data and information. When we're talking about data, we're talking about pieces, part of information. But information is a set of data. Okay, information is an uncountable noun. We don't say informations. We always say information. Okay, it isn't plural or singular. It depends on the context. Yeah. So information, when you're talking about information, is something with meaning. For example, my name Moises. My first name is Moises. This is a data, not an information. If I write Moises on a paper and I give the paper to someone, that doesn't mean anything to that guy, to that people. But if I run Moises eats banana, for example, this is an information, okay? I'm telling that people that there is someone called Moises or named Moises that eats banana. And what about knowledge and wisdom? Knowledge is nothing but true information. There is most of the information in the internet as well. They are not true. They are not right, correct informations. Most of the information are bad information, and you have to filter. You have to select which are the good informations. The true information are called knowledge. Okay. And wisdom is the quality you should have to apply your knowledge to for good things. If you apply your knowledge for bad things or badly, you're not being wise. Okay, you should have wisdom. You should apply the information to solve problems for the humanity, for the other guys, and to improve and to develop the society. Okay, so let's talk now about numeral systems. Numeral systems. We have four main numeral systems in computing. The one everybody knows is the decimal system. The decimal system is this one we all know. We all know the decimal system is the one we use in our school, in our everyday life. Okay, we use numbers from 0 to 9, but there is another system. The computer uses this system, this strange system with only zeros and ones. So all the information that in hardware a computer physical component understands is all zeros and one, is a bunch of zeros combined with ones. Okay, so octal is another system which is a little bit slower than decimal. As you see, it's only got 8 digits from 0 to 7. But this one, hexadecimal, is larger than decimal, and this is very useful as the binary. Nowadays, we are not using so much the octal system, but hexadecimal and binary are combined and used quite often. Okay, uh, 16 digits from 0 to 15, but from 10 to 15 we use letters from A, B, C, D, E to F. Okay, don't worry, this is to make easy, because if we had here 10 and 11, that would be a problem, because on the decimal system, when you have 1 followed by 2, you say 12. But on the hexadecimal system, if you have 1 followed by 2, you shouldn't say 12. You say 1, 2. Okay? Two different. This is a different way of seeing the things. So this is why we replaced the numbers with 2 digits by letters, so we can have single digits. Everything is a digit in hexadecimal. So we can convert from decimal to the other systems. As I was talking, first of all, this is an example of a decimal number with the base. The base is 10. Here, the 10 number with the base 10, the 20 number with the base 10. In decimal, the base is always 10. But this 10, in our everyday life, we don't use this base, okay? We only need to use this base when we're talking about numeral systems in comparison to the other systems, okay? Because for binaries, we have these kind of numbers. As you can see, only zeros and one, and the basis is always 2, the base, okay? Here in octals, the base is 8, okay? The base is 8. And hexadecimals, we have the base 16. Okay, if you want to convert from one of these systems to the other, you can use some online calculator, or you can create your own program to do that for you. So you learn to do both, but using this calculator is quite easy. Okay, you just open this link, and from there you can choose which system you want to start and which one you to convert to, and you have the conversion. But I don't want to be talking about using this site because it's quite easy. I want to teach you how to convert manually from one to another. Okay, this is another link for you to use about the ASCII tables. There are lots of websites which present to you the ASCII table. ASCII table is a very useful table. This is American Standard Code for Information Interchange. Um, in this table, you'll find numbers from 0 to 255, okay? And all those numbers in these, in decimal, binaries, hexadecimals, there are some ASCII tables which you'll find octals as well. But don't worry so much about octals, okay? Because I haven't been seeing people using octals, even in operating systems and complex systems. We're not uh, used to use octals anymore. We use hexadecimals instead. Okay, so let me uh, let me show you how to convert from decimal to another system. But since I'm presenting this video live, let me check the session. I have some comments right here. They are in Portuguese, so I'm not going to show you the comments in Portuguese, because this channel is intended to be for non-Portuguese speakers. As you can see, my I'm native to I'm native in Portuguese, not in English. I'm presenting this video in English for the whole world. So let's make some conversions. The conversion from decimal to one of these three systems is quite easy. You just need to perform some integer divisions, okay, using the base. If you want to convert to binary, you use the base 2. To octal, you use the base 8. To hexadecimal, you use the base 16. So let's convert the number 20 from decimal to binary. So if we want to convert to binary, let's use the base 2. So we divide 20, the original number, by 2, and we get 10. This is an integer division. It doesn't admit commas, dot, without floating point, only integer, okay? So we have 10. 20 divided by 2 is 10. And the remainder is 0, okay? Now we're going to divide 10 by 2. 10 dividing by 2, we have 5 with 0 as a reminder, okay? It's just a reminder. In order to make sure the division is right, you do the inverse operation. For example, if you multiply 2 by 5, you get 10. If you multiply 2 by 10, you get 20, okay? So right now we're here on 5. Let's continue with our division. 5 divided by 2. I know that we cannot divide 5 by 2. But since this is an integer division, we have to find an approximate number to perform the division. The closest number we can use here is 2, because 2 multiplied by these 2 will give us 4. We say it is 2 and not 3, because if you multiply 3 by 2, we would get 6. And the number should always be equal or less than this one. So this is why we're using 2, okay? And the rest is 1, because 2 times 2 is equals to 4. And in order to reach 5, we're missing 1. So the rest is the remainder is 1. Let's continue. We have 2 here. Let's divide 2 by 2. We got 1. The rest is 0. Let's divide this one. Continuing. 1 dividing by 2. We know that 1 the one integer value is not divisible by 2. This is why we have to find a number to multiply by 2 which will give us something closer to 1. This number is 0 because if we multiply 0 by 2, we get 1. We get 0, sorry. 0, which is closer to 1, okay, closer but less than 1. So the rest is 1 because from 0 to 1, we need 1. This is the remainder. Therefore, we're going to take all the remainders. We get 1 and put here. We get this 0 and put here. We get this 1 and put here. We get this 0 and put here, and the last one. So this 10100 is the corresponding in binary for this one for 20 in decimal. Now we're gonna perform another conversion, this time to octal. We use the base 8. So 100 divided by 8 is a little bit difficult division. So we find an approximate number, okay? This is 12. If you multiply 12 by 8 in your calculator, you probably will get 96, okay? This multiplying by this is 96. We're using 12 and not 13 because if we use 13 times 8 will give us a number higher than 100. And we don't want this. We want a number which is 100 or below, okay, less than 100. So this number is 12. 12 multiplied by 8 is 96. 96 to 100 is missing 4. This is why the remainder is 4. Now let's continue. 12 divided by 8, always 8 because we in octal, okay. 12 divided by 8, we need to find a number which multiplied by 8 will give us the closest as possible to 12, but not more than 12. This number is 1 because 1 multiplied by 8 is equals to 8. And from 8 to 12, we need 4. This is why the remainder is 4, okay? Let's continue. Now let's use this quotient, okay? The result. This result divided by 8, we perform the same operation. We find a number which multiplied by 8 is closer to 1. And 0 multiplied by 8 is 0. 0 is closer to 1. But the rest is 1. So since we got the 0 here as a result, we don't continue with the operations, okay? And we get the remainders, this 1, 4, 4. So 1, 4, 4 in octal is the corresponding to 100 in decimal. Let's do it for hexadecimal. For hexadecimal, we use 16 as the base, okay? 100 divided by 16, it's not divisible by 16. This is why we have to find some closest number. And this time is 6 because 6 times 16 is something like 96 or something like that, 96. And from 96 to 10, we can confirm 6 times 16 might be something like 96. Let's check it out. 6 times 16 right here. 6 multiplied by 16. Okay, this is the result, 96. Okay, so that's confirmed. We have 96, and from 96 to 100 it's missing 4. This is why the remainder is 4. Now let's use the result. 6 divided by 16, it's not divisible, so we use 0 because 0 times 16 is 0. And this is the closest possible to 6. And the remainder will be 6 itself. Okay, so we use all the remainders as well. 6, 4, and we have 6, 4. In the base is 16. Okay, this is how to convert from decimal to other numeral systems. So let's do the opposite. Here we have binary numbers, octal numbers, and hexadecimals. So from binary, this is easier than converting from decimal because we have only to perform multiplications instead of divisions. Okay, multiply, in my opinion, is easier than dividing. So you get 1 and put here, you get the 0 and put here, you get the last one and put here. Then you multiply each one by 2, by 2, by 2. And then you add the exponent. You add 0 here, 1, and 2. Notice that the exponent are put from the right to the left, okay? So 2 power 0 is equal to 1 because every number with an exponent of 0 is equal to 1, okay? This is 1, okay? So 2 power 1 is 2. Every number power 1 is itself. 2 power 2 is equal to 2, these 2 multiplied by itself. Some people make some confusion because they think that 2 power 2 means the multiplication of these 2 by these 2. No, that's wrong. This is a multiplication of this base by itself, okay? This is how power works. So 2 multiplied by 2 is 4. Here we have 4. Here we have 0 because of this 0, 0. And here we have 1. So 4 plus 1, we have 5. This is 5 in decimal. We just converted this number from binary to decimal. Here, we're going to perform the same operation, but in a bigger binary number. So 1, 0, 1, 1. And we have the base 2. And then we have 0, exponent, 1, 2, and 3. 2 power 3, it is equal to 2 multiplied by 2 multiplied by 2, 3 times. So this will be 2 multiplied by 2 is 4. The result 4 multiplied by 2 is 8. We have 8. Here we have 4 multiplied by 0. This is 0. Don't worry. Here we have 2 multiplied by 1. So 2 multiplied. No, that's sum. Okay. This is 2 summing by 8. This is 8. 8 plus 2, it is 10. And we have 1. 10 plus 1 is 11. So right here, the same operation. 1, 1, 1, 1, 1. And then we have 0, 1, 2, 3, 4. This time we have 4. 2 power 4 is equal to 16 because if this is 8, this is 8 times 2, which is 16. Okay, we have 16. Here we have 8. 16 plus 8 plus 2. No, sorry, 4 plus 4 plus 2 plus 1. And this is equal to 31 in decimal. We perform the same operation for octal. I'm going to show this first for octal, then you perform these operations by yourselves, okay? And these two also by yourselves. Let's do this together. We have 1, we have 2, this is 2, and we have 3, this 3. So we have the base 8, And then we have 0, the same operation. The only difference is on the base, okay? So 0, 1, 2. This is this is 1, this is 8, and this is 8 multiplied by 8, which is something like 64. So if you sum this 64 by this 16, this 3, you have 83 in decimal. And right here, we have hexadecimals, okay? Let me check how the video is going. That's fine. So here we have 2, 9, 16. Okay, this is the base. So we use the base multiplied by these two, and the 9 multiplied by the base. Here we put 0, and here we put 1. So this is 16 power 0, it is 1. So we keep the 9. Here we have 16 multiplied by 2, which is 32. This is 32 plus 9, which is equals to 41 in decimal. Okay, this is how you perform the conversion from other systems to decimal. Quite easy. If you have doubts, type here below in the comments, please, and I will answer your questions on the next video, in the next lesson too. Okay, the binary digits, we at the penultimate slide. This is about the binary digits. We're missing only a single slide, the most important slide, the most interesting slide for you, of course. So the binary digit we call bit. This is an acronym of binary digit, okay? By, this is bit. This is the B. You can use B and the final T, or you can use just the B and the IP, the final IP. You got bit. This is an acronym. Okay? With a bit, we can encode two different information, 0 and 1, quite easy. But with 2 bits, we can encode 4 information. Let's make some permutations. 0, 0, 1, 1, 0, 1, and 1, 0. These are the 4 only information we can encode using 2 bits. We using a combination of 2 bits, okay? Using a combination of 3 bits, we can encode 8 information. As you can see, it is raising on an exponential way. This is exponential. Okay, in an exponential way. Firstly we had 2, then we have 4, and then we have 8. Okay, this is exponential. So we have with 4 bits 16. In general, we have 2, which is the base for the binary system. 2 power n. Okay, 2 multiplied by itself any times. For example, if you have 8 bits, you can encode with this a huge bunch of 2 power 8 information. This is 260, 256 information. In numbers, you have numbers from 0 to 255. Okay. So there are some tricky names that we used to use in computing. So a half bit, a half byte, not a bit, because 8 bits we call byte. But if you have a half of a byte, which is 4 bits, with 4 instead of 8 bits, you can call this a nibble. Nibbles are very important because we used to represent a byte by 2 different hexadecimals. Okay, in practice, we represent each byte by 2 hexadecimals, and by convention, each hexadecimal contains four binaries, four bits, okay? And this is what we call enable. And this is 4 bytes, four bits, sorry. But if you have two bits, we call it crumb. Crumb is a very, very small portion, like a piece of food. This is a crumb, okay? Like a very small piece of bread you call crumb. Native guys in English know what I'm talking about, but this is what we call two single bits, okay? And if 8 bits we call a byte, there are some multiples of byte. For example, if we have 1024 bytes, we call this kilobyte. In the early uh, 20 this 20th century, we 21 sorry 21st century, we used to get some devices with the information represented in kilobyte because the devices were uh, too poor in capacity. So we used kilobytes in 2000, 2001 to 2005, something like that. Okay. Then we we moved to use megabytes. Megabytes. We don't use flash disks anymore. We use pen drives. Okay, not the old flash disks with kilobytes or bytes or even bytes, but megabytes, 154 bytes or kilobytes in this case. And then we have gigabyte, terabyte, petabyte, exabyte, zettabytes, and yottabyte. Okay, these are the units of information in computing and telecommunications as well. So we're gonna stop here for today. Okay, thanks a lot. Don't forget to follow Technique High Tech on YouTube, Facebook, Twitter, and Instagram. But next next session we'll start we'll start coding. We will code our first program and we'll perform some exercises using the information you learned today, but just coding, just using the C programming language to do this for us. Okay, thanks a lot for those who watched my video. Don't forget to follow my channel. So next week I'll be back. Just put on the comments, share the video with your friends, and we'll be learning together. Thanks a lot. Okay. See you guys.